Why did you want to be an astronaut?
And I have to say, I don't know why I wanted to become an astronaut. You know, I think it's everybody goes through this when you're searching for what you want to do in life, and what is it that makes you pick a particular path. I don't know what the answer is. I just know when I look at or I think about what an astronaut does, that gets me excited. I get very passionate about it, and I know there's people out there with different career fields have that same kind of passion, that same kind of desire. So it's just something that came from within. I've been very blessed to get the opportunity to follow that passion, that dream, and so. But what it is, I can't put words to it.
Let me get you to put words to a few other things. We want to find out more about Mike Hopkins. Tell me about your own background. Start with your hometown and where you grew up and what that place was like.
So I grew up on a farm in rural Missouri, and really I kind of look at two hometowns. So when up through grade school, I went to one school, one hometown, and then as I got into junior high and high school, I changed schools and went to a different location. But both of those towns, small communities, communities where everybody knows everybody, where there's you rely on each other, you help each other, and really for me, I think it gave me an opportunity to participate and develop that maybe sometimes in larger cities or schools you sometimes don't get, and so that was important for me because I got to try a lot of different things. And whether it was sports or whether it was being in the school play, or that maybe I wouldn't have had that opportunity in a larger community.
I was going to ask, participate in what? What were the different things that you were involved in?
Well, so certainly I was involved in all of the athletic teams that we had, or the traditional ones, I'll say, for small communities of football, basketball, track and field. But I also was in the school play. When I was taking typing, I was participating in competitions for typing, and so just it gave me those kind of opportunities that, again, when I look at the larger schools, when you have this huge pool of kids to choose from, you may have to just select one or two things to do because there's just so many other people that also want to participate. And so for me, again, I think it worked out very well.
When it came time to leave there, to go to college, what were you thinking about when you chose where you wanted to go next?
Well, I chose to go to the University of Illinois, and again, was very fortunate that they accepted me. Primarily, I was looking at the engineering school. I wanted to go into aerospace engineering, and so their program was one that I thought matched what I was interested in. And then at the same time, I decided to try and walk onto the football team, and they were willing to give me a shot. And so that also, I guess, was a nice opportunity to have.
Two things then that I have to follow up on. Did the interest in aerospace engineering come from? Why was that something that you were looking for in a college?
Well, I knew I was interested in engineering. My father was a pilot in the Marines back in the early 60s. He flew A4s, and so there was aviation in my family. My uncle actually was a pilot as well in the Air Force, and so that certainly piqued my interest in it and my interest in space. My desire to become an astronaut started back in high school, and at the time that seemed like the logical field to go into.
When you were in high school, what was going on in space exploration at the time?
So at that time was the early days of the shuttle program, and that certainly helped kindle that fire in me for space exploration, is watching those early missions of the space shuttle.
And the other thing you said that you also had the opportunity to play college football.
I did, and what a wonderful experience, an experience that I think was important for my progression and development in being able to become an astronaut, because when you participate on the team like that, you need to learn to work together. You succeed or you fail as a team, and so I think that was an important part of my growing up.
What position did you play, and how well did your teams do?
So I played defensive back, both strong safety and free safety, and I had the good fortune of going to 4 bowl games while I was there. So we had some success.
Mm-hmm. Now, in the process of going through college, you also got involved in working toward the Air Force, right?
That's correct. While I was in college at the University of Illinois, I was in ROTC, Reserve Officer Training Corps, which meant when I graduated, I was commissioned into the Air Force.
With the idea that you would use your aerospace engineering knowledge in the Air Force.
That's correct. And so when I first came into the Air Force, I was working at one of their laboratories in Kirtland Air Force Base, Kirtland Air Force Base in Albuquerque, New Mexico. And then I got into flight test, and as a flight test engineer, and so I had an opportunity to go out to Edwards Air Force Base in California, where the Air Force does a lot of its flight test. And so I went through the school there, and I stayed on a couple years and got to test airplanes, and then followed that up with an assignment up in Canada at their flight test center as an exchange officer, and got to continue testing airplanes. So I really enjoyed that job that I got to do in the Air Force, because I was taking that classroom work of learning about aerospace engineering, understanding aerospace engineering, and getting to apply it firsthand in airplanes and jets. And so that was just a wonderful experience.
Your job was as a flight test engineer.
That's
Explain
correct.
to people what that means.
Yeah, so most people are going to understand what a test pilot is doing. So he's the guy actually flying the jet. And as a flight test engineer, oftentimes we're sitting on the ground through a control room directing that pilot as he executes the test. But many times we also get to fly with them as we're executing a test. And so the flight test engineer oftentimes is the person that's directing the test. So he's telling which test point we're doing, what the conditions are, and then as you're executing that maneuver, the flight test engineer times is recording the data while the pilot flies the airplanes. And so as you go through the school, a lot of what you learn is how to communicate between you and the pilots. So sometimes you're doing this translation between the engineering world and the pilots, and making sure everybody understands what the airplane is doing and what the data means.
The course of your Air Force career, you also did some other work, ultimately working in the Pentagon.
That's correct. I followed up my flight test work with an assignment actually to Italy first, where I got to be a political science student over in Italy for a couple years, and then I went to the Pentagon, where I got to work in the acquisition side of the Air Force. And so I spent 3 years there. Had some just fascinating projects that I got to work on, and that got followed up with an assignment on the staff of the Vice Chairman of the Joint Chiefs of Staff. And that was just an amazing experience to be able to see how the Department of Defense operates at that level was truly amazing.
At some point in all of that, you applied to become an astronaut. What spurred you to make that application?
Well, I actually applied multiple times to be an astronaut. In fact, when I got selected, that was my fourth application for it. So again, it goes back to I'd always had that desire to try and become an astronaut, and so at the first opportunity that I had, I started applying, and I just continued applying each time there was a new selection process happening, and I was very fortunate on the fourth try to get in.
And now you're going to become one of, it's actually just a little more than 200 different human beings who've actually been on the International Space Station so far. What are your hopes about how you can use your mission to inspire the other people who want to be astronauts and want to go to the space station and want to go beyond that?
So I think you inspire people by your actions and your accomplishments and the things that you do. So when you look at the International Space Station as a whole, the inspiration is there. The inspiration of what you can accomplish when you cooperate and you work together is truly amazing. The inspiration that you have this national laboratory that the private sector and scientists can now start to use in doing experiments in ways that they maybe hadn't thought of before, because now we have this laboratory where you're working in microgravity, and so you take that 1G variable out of the equation. And then the station itself is certainly an accomplishment all by itself, but when you look at it as the stepping stone for future exploration, for going beyond low Earth orbit, to me that's all the inspiration a person would need.
You're about to fly in space and do a part of this job that admittedly has some risk to it. I assume that you think the risk is reasonable and worthwhile. The question is why? What is it that we're getting? What are we learning as a result of flying you and other people in space that makes it worth taking that risk?
Well, I'm going to steal an answer I used earlier, and that is the knowledge that we gain. Again, not only about ourselves, but the universe in which we live. And so I think humans are always striving for knowledge, for knowing what's beyond the hill, for knowing how each little thing works in our world, whether it's the human itself, whether it's anything within biology, the physical world, all of that, we have this desire to know as much as we can about that. And the space station, the International Space Station, fits right into that. We are gaining so much knowledge every day from what we're doing up there that I think that makes it well worth the risk.
You and your crewmates are next in line to launch to the International Space Station.
Yeah.
Mike, what are the goals of this mission, and what are your jobs going to be on the station?
Yeah, so the goals of the mission really are to continue executing the mission that Expedition 36 is doing right now. And what that means is maintaining the space station so that we can execute the science objectives, and then leaving it in good shape for future expeditions so it's still there and operating and ready for them to do their missions as well. And our job, my role, is really to be a jack of all trade. What that means is I have to be able to maintain the space station, whether it's routine maintenance or whether it's something breaks and we need to fix one of the systems on board. I need to be able to do an EVA if called upon to do that, operate the robotic arms for when we have visiting vehicles, supply vehicles that we need to capture, and execute the science mission. And in many cases that gets very involved because we're human guinea pigs while we're up there.
That is a lot of different things in a lot of different areas. How hard has it been as you trained to trying to hold all that knowledge together?
Yeah, so very difficult, but fortunately there's been a lot of crews that have gone before me and my crew, and so they've really fine-tuned the program, the training program, and they do a fantastic job. The trainers are absolutely amazing, and the program is well designed, well executed. It's a 2.5-year training flow. So by the time you reach this point, you definitely feel like you're ready to go.
You spent that time, and actually more time than that, studying this vehicle. On your first trip to space, what is it that you're most looking forward to seeing?
Well, first and foremost is going to be the smiling faces of our crewmates when we open that hatch to the International Space Station. I can't wait to see them because you finally arrived at that point. And then just in general, I think you'll probably hear this from a lot of astronauts, is just the opportunity to see the Earth going by in all its glory and all its beauty. You see pictures of it, but to actually get to experience that firsthand, I think is just going to be incredible.
The International Space Station has changed a lot in the time that you've been at NASA. In fact, you're going to be on orbit for the 15th anniversary of the launch of the Zarya module, which was the very first component of the station to fly. What do you think about what this station has become in that amount of time?
Yeah, it's truly incredible when you think about when Zarya launched 15 years ago and to where it is now. The size of a small 5-bedroom house, or actually quite large, and it just is a testament to the work of people from all the participating countries, all the crews, all the flights from shuttles to Soyuz to resupply vehicles that have gone on before. It's truly incredible, and I definitely feel honored just to be able to have a small part in it.
The assembly of the station is pretty much complete,
right,
and so all the attention is really getting more and more focused on the science work that you folks are doing, along with maintaining the facility to keep it going. How do you convey to somebody the potential for what it's possible for us to learn using this laboratory in space?
Yeah, it's very difficult because the potential, sometimes you could say, is almost limitless. We get to understand a lot about ourselves, about our bodies, how we adapt to the space environment, but then what we learn can also be applied to life here on Earth. We get to learn about the physical environment in which we live and Earth, and we get to learn about the universe that our solar system and Earth is a part of. And so all of these things are just out there ready to be discovered, to be learned, utilizing this incredible asset.
The big area of concentration for the science on board is learning how human beings can survive and thrive in this environment, what it does to the human body. In fact, the station program has recently announced that they're going to send 2 crew members there for a full year in order to gather more information about how people are living in this environment. What are your thoughts about a year-long mission for a crew on the station?
Well, first, I think it's an important step for learning about how the human body adapts to space for that long of a time, for a year. And it's important for us, if we're going to take the next step beyond low Earth orbit and visit the moon again or go to an asteroid or even onto Mars, we need to have a good understanding of that. And the space station is an excellent platform for learning that information, for discovering what happens to us in that time frame. And the crew that they've selected, I think, are the right crew for it as well, experienced crew, and I expect we're going to see some very interesting results from that.
Would you like to go for a year if they gave you the chance?
Well, of course, I would certainly relish the opportunities to fly in space again, but let's get through my first mission first.
Let's talk about this area of science. As we say, what happens to people in this environment is crucial to future exploration. Can you give me 2 or 3 examples of human life sciences experiments that you are going to be involved with on this flight?
Yeah, one of them is the Pro-K experiment, and that's where we're looking at the ratio between animal proteins and potassium and how that affects bone loss. And so the idea is that if we can figure out what that right ratio is, we might be able to minimize the bone loss through just nutrition. And so very easily you can see the applications for not only long-duration spaceflight, but also down on Earth, because as we get older we experience some of the same negative effects of bone loss that we experience in space. And so if just with nutrition we're able to help mitigate that, that would be fantastic. Another one that I find very interesting is the spinal ultrasound experiment. So as when we go into space, fortunately for someone like me, we tend to grow a little bit. So I might actually be a little bit taller. But what's happening to the spine? And so we don't necessarily understand where that growth comes from. And so we're taking a look at ultrasound as a method to being able to determine that. And we can compare that data to MRIs that we've taken of my spine here on Earth. And so that'll help us understand what's going on with the spine in space. But then the nice side effect from this, or the benefit from that, is these techniques that are being developed, utilizing a ultrasound imaging with a non-medical expert that's doing it up on the space station. Those techniques are applicable down to the ground. So now imagine a remote community that doesn't have an MRI there, but you've got someone with a spinal injury. Well, if you have an ultrasound machine and someone that can operate that machine through remote guidance, they may be able to help determine what kind of injuries that person may have. So the benefits are not just for spaceflight in that case, but also for here on the ground.
That's a couple of examples, good examples of things that you're going to be actively doing. You're just being there is part of an experiment too, right?
Exactly, yeah. That our bodies change when we get up there. We don't need as much fluid when we get up there. We have this bone loss. We have the muscle mass loss. We get taller. So all of those effects, we want to try and understand really what's happening and how can we mitigate some of those effects if they're negative. And so yeah, just being there, we are an experiment in work.
Now, that's one area of science, is human life sciences.
Yeah.
This space station has got several laboratories that are filled with specialized equipment to conduct science in other areas of research, and you and your crewmates are going to be involved in a number of those. Can you give us a taste of what other kind of work you're going to be doing apart from experimenting on yourself during the time that you're in space?
Well, what's interesting is some of those experiments aren't actually even inside. There's a lot of experiments, or several experiments, are on the outside of the space station, and oftentimes those experiments we don't necessarily have a lot of direct involvement in, other than we're maintaining the station and providing power and cooling and things like that they may need. So, for example, there's MAXI, which is looking at cosmic X-rays, and they've had some very interesting results. In fact, I think they were able to help detect a black hole shredding a star, and so that's just fascinating. Not only is it fascinating, but it helps you understand a little bit more about the universe. So there's these experiments that are not just inside, but also outside like that. On the inside, for example, we've got a capillary flow experiment where we're looking how fluid behaves in the microgravity environment, and through this experiment we may be able to move fluids around without the need for a pump, be able to remove gases from that fluid without the need for a rotating pump or something of that nature. And so those results also are extremely interesting, and it'll be fascinating to actually get to participate and help execute that.
Let me ask you, in the case of the capillary flow experiment you were just talking about, why would it be important to know how to move fluids or to remove gas from fluids without this other mechanism, without a pump or something? How's that applicable?
Yeah, certainly those, the more pieces of machinery, the more complicated a system is, the more opportunities for it to break down, the more opportunities for it not to function properly. So if you can remove some of those pieces, and you can potentially improve efficiencies, you can make things more reliable, as an example. But so, you know, a lot of this research that's going on is very basic research as well, and so we don't know exactly what the applications are going to be yet, but that understanding that we're gaining by executing these experiments on station, you know, it's limitless what we may be able to do with some of this knowledge in the future. It
sounds like you may even be helping develop the machines or the technology that we need to do that exploration in the future.
Well, I think a lot of the science on board is geared towards space exploration. That's what NASA does. But also, this national laboratory is an asset, and we actually allocate some of those assets towards experiments that benefit life on Earth. So we're looking towards the private sector, and to utilize this national laboratory for microgravity-based research.
Talking about different kinds of science that you do, not only on yourself but in the laboratories. And you made reference a minute ago to one of the important things, one of the science things you do is keep the station running so it can support all that other experiment work. Yeah. Give us a sense of what is involved with that. I mean, you're not building the station anymore, and it's been there for a long time, so it operates pretty well. What has to be done on a day-to-day or week-to-week basis by the human crew members in order to support it?
Well, in many senses, the space station isn't all that different from your own home. We have cooling and heating systems. We have plumbing systems. We have bathrooms and all of those things, just like your home, sometimes break down or sometimes need routine maintenance. And so we have to execute those, and depending on whether something breaks or not, they'll often dictate what our day looks like. So one of the neat things about there, I think, is up on station is every day is going to be a little bit different, because sometimes you just don't know for example, when the WHC, that's our toilet on board, when it breaks, a lot of the other work gets put on the back burners until we get that system fixed. So every day can be a little bit different. It's going to be executing science experiments. It's going to be having some system maintenance. There's always going to be working out on board, which is very important for us to maintain our health. And then, of course, you still have to do the normal things like eat and sleep and live.
The exercise that you referred to, as you said, is something that all crew members have to do. Right. But it's a particular interest of yours. Tell me about how you're going to try to work that required exercise into your own program.
So exercise has always been a huge part of my life since the time I was little all the way up through college, and even beyond that through my career in the Air Force. It's just something I've always been very passionate about. I've been very fortunate and had opportunities to play in sports all the way up in the collegiate level. And so I've wanted to try and share that passion, if you will, a little bit with people. And if I can hopefully inspire people to get out and exercise a little bit by seeing how important it is to us on station, whether it be kids or adults, and at the same time pique their interest a little bit in the space flight and all of that, I think that would be fantastic. And so I'm trying to gear up a little bit with the Train Like an Astronaut program, highlight that, where it's a program that tries to motivate kids to get out and exercise, because healthy kids are going to turn into healthy adults. And so I'll tie into a little bit of that, and through avenues like Facebook, we're going to share some of the videos of my workouts on station, and we'll put out there some of our not only videos of it, but also the types of workout that I'm doing, and maybe some motivational clips and things like that. So hopefully we can reach out to some people that may not think about space as much. People that are very interested in the physical fitness things, and they may not just realize how critical it is to spaceflight.
It is. It's a 2.5 hour a daily commitment. That's, I don't know, is that more than what you normally do now? Yeah,
it certainly is. What a wonderful opportunity to have 2.5 hours put on your schedule every day for working out. I mean, that's a dream come true for me. So yeah, it's absolutely, and that I think highlights how important it is. When you think about what it takes to have built this station over the years, and what it takes to put a person up on it, their time is valuable, and yet at the same time we realize how important it is to keep them healthy, and in order to do that, we need to allocate that time for exercise.
Exercise on a daily basis is part of what you do. Maintenance is part of it. Science work is part of it. And that's what it's like for most of your mission.
Right.
And yet there are some more dramatic periods of the mission. For you and your crewmates, one of those periods is going to be in November, when for most of a week you're going to have 9 crew members on board all at the same time. What's causing that change in the usual situation?
Right. Yeah, so it's going to be a very exciting time. So normally what happens is a 3-person Soyuz crew departs before the next three-person crew arrives, and usually there's a gap of 2 to 3 weeks in between there, where you're only going to have 3 people up on station. In this particular case, what's driving the 9 people on station, so what that means is Karen Nyberg, Luca Parmitano, and Fyodor Yurchikhin, they won't depart before the next crew arrives, because that next crew is bringing up the Olympic torch. And so during that period of time, for about 4 or 5 days, we'll have the Olympic torch on board, and then Karen and Luca and Fyodor will take the torch and back home with them.
This is part of the Olympic torch relay, I think,
I guess you could say so, yeah.
And in fact, the torch is going out the door.
That's right. I don't know all the details of that particular EVA yet, but during that period of time, which is going to be very busy, there's going to be a redocking or relocation of one of the Soyuzes while we're there. Then the torch arrives. There'll be an EVA, and then there'll be the departure of Karen, Luca, and Fyodor. So very busy time. What happens during that EVA, a lot of those little details are still to be worked out. But certainly we're all very excited to have an opportunity to participate in really, I think, this momentous event of the Olympics.
Well, I want to ask you more about that, too, in a moment. But while we're on the subject of spacewalks, which is a very fluid sort of thing for all missions, spacewalks get planned and sometimes don't happen. What at this point is the plan for Russian and American spacewalks during your time on orbit?
All right, so currently on the U.S. side, the USOS side, we don't have any planned EVAs during our time on orbit. However, on the Russian side, the current plan was for 7 EVAs during the time, and a lot of that is tied towards the multi-purpose laboratory module. So going to be a very busy time for them as far as it goes with EVAs, and so we'll see how all that actually plays out.
When your Russian crewmates do spacewalks, do you and the other U.S. segment crew members have a support role to play?
Our role during the spacewalks itself is very minimal. We will help get ready for the spacewalks. We provide some equipment, and so we'll have to go through the procedures to make sure all of that's available to our Russian crewmates. And then it really depends on, as far as the USOS involvement, it really depends on where your Soyuz is located. So, for example, my Soyuz is going to be located on the Mim Deva module, and that puts me in a position where I need to be in or close to my Soyuz, and so I'll be isolated actually from the USOS segment during the spacewalk. On the other hand, Rick and Koichi, for example, their Soyuz is located on the forward end of Zarya, and so their Soyuz is accessible to them from the USOS side, so they'll have the full range of the USOS segment to operate and work in. So it kind of depends on where you're located, and in my case, I'll be down in one of the Russian modules, and so what I'll be able to do during that time will be somewhat limited.
Except maybe look out the window.
Which isn't a bad thing.
You made a reference to the fact that a lot of that plan has to do with getting ready for a new Russian module.
Right.
When we said that the station was essentially complete, it's not completely complete.
Right.
There is a plan for another Russian laboratory module called the multipurpose laboratory module, the MLM, that is scheduled to come either late this year or later. Briefly, what does that module add to the station? What does it do?
Yeah, actually, it increases the capabilities of the station from a science perspective and from a life support perspective. So from the outside, it actually looks very similar to Zarya, that first module that was launched into space 15 years ago. But on the inside, it's quite a bit different. It's got capacity for a lot of science experiments, as well as some of that life support equipment that currently resides back in the service module of the space station, the Russian segment. And so there'll be backup life support equipment. There'll be another toilet. There'll be another sleeping quarters. And so it really expands not only science, but also that critical life support role.
Another, or not another, but some other of the dramatic or dynamic events that take place when the station gets new supplies delivered on uncrewed cargo ships. And there's a little armada of supply ships nowadays that comes to the space station, including a couple of new commercial American vehicles. Give us a little primer on the different supply ships that are involved now in keeping the station operating.
Yeah, it's actually fantastic to have such a large number, if you will, of different vehicles that can supply the station. So in August, so this will be before I actually arrive to station, the Japanese supply vehicle HTV-4 is slated to arrive, and it should be completely unloaded and reloaded and undocked before I get there. Then what's coming next is the orbital vehicle, the Cygnus vehicle, and that's their demonstration vehicle, and it should also arrive before I get there, but is slated to undock after I do arrive. And so that'll be certainly a momentous occasion to welcome another new commercial partner to the space station. That is also slated to potentially follow up with another orbital vehicle in December, and then another, potentially a SpaceX, the SpaceX 3 vehicle could also be coming aboard in that time frame.
And there are also supply ships from the Russians and the Europeans that are involved.
Yeah, you certainly don't want to forget them. The Progress vehicles that the Russians launch have been the backbone of resupply for the station for a long time now, and ATV, which is docked to the station at this time, which is the European supply vehicle. So all of those are critical to keeping the station flying.
A few minutes ago, we made a reference to the Olympic torch relay, which this time around is actually going through the space station. It'll be during the last few weeks of your time on orbit that the Winter Olympics are going to start in the Russian city of Sochi. What do you think it's going to be like for you and your crewmates, this international group on the space station, to be there doing this work while there's this international activity taking place on the ground?
Yeah, I think it's going to be a very special time for us. Certainly there's a lot of parallels between the Olympics and the station, and what I mean by that is they both take an amazing amount of international cooperation for them to succeed. And so you see that on the space station, and you're going to see that on the ground. And then at the same time, there's a few differences. I don't think on board we're competing quite like the athletes will be competing down during the Olympics. But at the same time, there's such a positive feeling that comes out of the Olympics, and I think you see that same kind of positive experience happening up on board station.
It's not to say that you couldn't be having your own competitions at the same time.
Yeah, we'd have to figure out what events we would do, but snow skiing might be a little tough on station.
And your team, you think your team might have an advantage with you on it?
Well, I don't know about that. Our Russian crewmates are certainly all very good athletes in their own rights, and Koichi, when he's there, will certainly be able to hold his own.
I think by that time you'd all have become accustomed to the environment and and would be very sharp in
it would be interesting to see what the events would look like.
What are you most looking forward to about the flight in general? About your part in this program now?
So, yeah, that's a very tough question, because there's a lot of things that you're looking forward to, and I have to, I think first is actually getting the opportunity to execute the mission. So we talked earlier about all of this training that we've done to get ready for it, and I kind of equate it to it's been the preseason before football season, or it's a young kid that's finishing college. He's spent the last 4 years studying, and he's finally has that first job, and he's going to go out and execute. And so I'm looking forward to doing the job that I was trained to do. I think that's going to be very exciting. I'm very excited to represent my family, to represent my classmates here at NASA, to represent NASA in general and the country as a whole. And then finally, and this one might seem a little strange to say, but I'm also looking forward to coming home. Though I'm certainly going to cherish every single moment I have up on space station, one of the great things about leaving home is coming home. And being reunited with my family, I think, is going to be absolutely wonderful. And so to say, I certainly have to say, actually, that I'm looking forward to that.
When all is said and done, if you think about it, tell me what it is you think that we are learning overall from all of these missions to the International Space Station that is preparing us for the future human exploration beyond low Earth orbit.
Yeah, wow, that's a big question as well. I think in a very broad sense, knowledge. I mean, we are just gaining knowledge about so many different things from the International Space Station. We're learning about ourselves. We're learning about how our bodies adapt up there. We're learning about the world in which we live. We're learning about the machines that it takes to get us there, and how those systems operate, and how often they need to be repaired, and what works and what hasn't worked. And so all of those are such a critical part of taking that next step and going beyond low Earth orbit and continuing human exploration.